This section explains how tires are produced. These are the main stages of tire production. The basic components in tires are steel wires and cord, natural and synthetic rubber, various chemicals, and carbon black. The dominant component in tires is rubber. 8,000 kilometers from the heart of Europe, rubber trees are grown. Incisions are made to harvest the liquid latex. Natural rubber is the most important product obtained from the latex. Rubber is then transported to the production plant with the rest of the raw materials and components. In a laboratory, the quality and physical properties of the rubber are tested. If the sample complies with our stringent requirements, the batch is delivered to the mixing room. Rubber compound mixing. The first stage of tire production is rubber compound mixing. At the rubber mill, the rubber is mixed with various materials. These include fillers, clay, and carbon black. At the last stage of mixing, sulfur and curing agents are added. The resulting compounds have various properties. Some are used for the inner liner, which holds air inside the tire, and others are wear-resistant and are used to make the tread. In the laboratory, the density of cured samples and other physical and mechanical properties are measured. The resulting blend is formed into rubber sheets and cooled. Each batch is weighed and identified. After additional testing, the rubber compounds are used in further processing. Next, we will show the basic components that make a tire. The components are produced during further processing. These are bead wires and rubber-coated cord. Other components are extruded and calendared from various rubber components. This animation displays the basic components of an agricultural tire. The inner liner is used in tubeless tires. This is the first carcass ply. Then the bead core and bead wire. And then another carcass ply, bead lining, and rim strip. These are belt plies. And finally, the sidewall and tread. Extruding and calendaring of tire components. The mixing rubber compound is used for calendaring the inner liner and extruding the tread and sidewall. First, the rubber compound is heated. Then the compound is put through extruder machines, where the tread and sidewalls are formed into required shapes. The extruders produce a continuous sheet of tread rubber. The sheet is then cooled and cut to specific tire lengths. The inner liner is produced by calendaring. Rubber coating. The mixed rubber compound is also used for rubber coating. Sheets of cord such as nylon, polyester, and steel are thinly coated with rubber on both sides. Once this is finished, the sheets are cut at the correct angle, which determines the tire's characteristics. These cut sheets are used for casing, belts, and other plies. Steel cords are mainly used for the belts placed under the tread and sometimes for the casing. Bead wire. Next, the bead wire is produced from rubber and steel. The bead core is formed by aligning and coating steel wires with rubber. Then, the wire is wound on a coil to form bead rings. The number of loops and shape of the bead wire are specific for each tire. Tire building. At this stage, all the tire components are assembled. The tire is made from components on a tire building drum. Tire building begins with the sidewall and rim strip. This is the bead lining, inner liner, and two carcass plies. Bead cores are placed on the building drum. Then the ply edges are wrapped around the bead core and the sidewalls are moved into position while the tire is reshaped. After inflation, the belts and tread rubber are applied. For large tires, the tread rubber is wound onto belt plies. This process achieves a green tire that already resembles the final product. The differences between radial and bias ply tires. There are two kinds of tires: older bias ply tires and newer radial ply tires. This animation highlights the tire casing. In a bias ply tire, the cord is laid at an angle of 60 degrees relative to the tire's movement. Successive plies are laid at opposing angles, forming a crisscross pattern. Now, in the radial ply tire, the cord in the casing ply is laid at a right angle to the center of the tread. Radial ply tires are more complicated to produce, but they have new characteristics. For example, radial ply tires save fuel, last longer, and improve riding comfort. Agricultural radial tires apply less pressure on the soil and thus protect plant roots. Curing of the green tire. After tire building, green tires are cured at a process called vulcanization, in which the tire achieves its final shape and characteristics. This is a tire mold. Prior to curing, the green tire is covered with a solution that helps the green tire fill the mold. The green tire is placed in the curing press. The curing medium pushes the green tire into the mold. The rubber compound is heated and becomes plastic. It fills the mold. The vent system lets the excess air escape the mold so that the rubber fills the mold completely. The applied heat also initiates a process called vulcanization. This is the basic element of natural rubber molecule. It's a polymer. During vulcanization, these polymers are linked by sulfur. This changes the molecular structure into a three-dimensional pattern of interlinked polymers. The vulcanization of a passenger car tire takes only a few minutes. For an agricultural tire, this process can take up to 2 hours. This is a final product, a cured tire. Finishing and final inspection. Before the tire is dispatched from the plant, it is trimmed to order and inspected. Each tire is visually inspected for surface defects. Testing machines measure the compliance of central and lateral runout with the norms. All tires undergo a uniformity test. Tires containing steel cords are inspected by X-ray for internal defects. The final inspection is the last stage of the tire production. The tire is then stored and ready to be dispatched to customers.